Learning objectives. By the end of this course, you should be able to describe what oily bilge water is, identify oily bilge water, demonstrate how to operate the equipment installed for handling oily bilge water in the proper way, and describe the requirements of MARPOL Annex 1 regarding oily bilge water. Section 1. Introduction. Section 2. History of oily water pollution prevention regulations. Section 3. Oily water separator, oily filtering equipment. And Section 4. Common oily bilge water piping system on a vessel.
Section 1. Introduction. Introduction. Since 1911, when Selandia started to sail powered by a diesel engine, the oil pollution of the sea started. As this kind of power plant requires less space than the steam plant, thus enabling more space for the cargo, the number of these ships rapidly increased. With increased numbers of vessels in the shipping business, the oil pollution of the sea is becoming more significant, because there were no rules that would regulate the handling of these pollutants. An international conference in 1954 created the Oil-Paul Convention in an attempt to reduce this pollution. One of the pollutants detected was oily bilge water from the engine room, and consequently, the regulations regarding handling this water were created. The Oil-Paul Convention was not efficient in the prevention of sea pollution by oil. The MARPOL Convention was created in 1973, and the modified Oil-Paul Convention was included in MARPOL as Annex 1. The new technology has introduced 15 ppm parts per million oily filtering equipment for oily bilge water treatment. This equipment required different regulations regarding its use. In the beginning, this equipment was without an auto-stop device. With Annex 1, special areas are created, and the use of this kind of equipment was not allowed in special areas. The new oily filtering equipment usually requires an auto-stop device, and consequently, it may be used in special areas. The standard name for oily filtering equipment in Europe is oily water separator. In the USA, the valid name is oily filtering equipment. Section 2. History of oily water pollution prevention regulations. History. Definitions. Oily water. Oily water is a mixture of oil and water where the content of the water is exceeding 30%. Oily bilge water. Oily bilge water is water collected in bilge wells or tank tops. This water may be contaminated with any oil resulting from engine leakage. Contamination may be the result of some piping breakdown or some leakage that happens during maintenance. Contamination may be the result of mixing with some cleaning solvents, too. Bilge water holding tank. The bilge water holding tank is the tank where the water accumulated in bilge wells will be transferred for later disposal. MARPOL's evolution. The oil pool was an international treaty signed in London on the 12th of May 1954. It was subsumed by the MARPOL in 1973. It was agreed that every vessel above 500 gross tonnage must have a 100 ppm oily water separator. The bilge pump was serving as the service pump for this unit. The bilge water could be pumped out when the vessel was underway, and the distance to the nearest land was at least 50 nautical miles. This distance was regulated differently in established prohibited zones. Through amendments in 1962 and 1969, some provisions were changed. If discharges are made when the vessel is underway, and without using a 100 ppm unit, the instantaneous quantity should not exceed 60 liters per nautical mile. When the 100 ppm unit is used for discharging, this limitation is not applicable. The vessel, during that operation, must be as far as practicable from the nearest land. MARPOL 73 to 78. Click on the icons to learn more. The MARPOL Convention was adopted in November 1973. It needed ratification by 15 states, with no less than 50% of the world's shipping by gross tonnage. Only Jordan, Kenya, and Tunisia ratified the convention, presenting only 1% of the world's shipping gross tonnage. There was a spate of tanker accidents between 1976 and 1977 that resulted in the Protocol of 1978, which absorbed the parent convention. The document, named MARPOL 73 to 78, entered into force in October 1983. Section 3. Oily water separator, oily filtering equipment. An oily water separator is a filter designed to reduce the number of oil particles in water discharged overboard to a maximum of 15 ppm, parts per million. There are two types of oily water separators: the stationary type and the centrifugal type. The stationary type uses coalescers that are producing larger oil drops that are easier to separate from the water, and a filter is additionally cleaning the outflowing water. All vessels from 400 gross tonnage up to 10,000 gross tonnage must have equipment that will prevent discharge into the sea of effluent with more than a 15 ppm oil content. All vessels above 10,000 gross tonnage must have equipment that will prevent discharge into the sea of effluent with more than a 15 ppm oil content, and additionally, they must have the unit equipped with an auto-stop device when that limit is exceeded. Click on the button to view the oily water separators diagram. Every oily water separator, OWS, should be provided with a recirculating system that includes an oil content monitor, OCM, 15 ppm alarm, and an automatic stopping device. The system enables testing the 15 ppm alarm and the functionality of the three-way valve without opening the overboard valve. Vessels with less than 400 gross tonnage do not need to be provided with an OWS, but the capacity of the tank must be enough to keep oily water on the vessel until it is possible to dispose of it at some shore facility. These vessels may have the equipment, with a design approved by the administration, for discharging oily water with an oil content of less than 15 ppm, while the vessel is en route. Whenever discharging the oily water from the engine room is mentioned, there must not be any traces of the cargo present. Oily water separator (OWS). The centrifugal type is using centrifugal force for the separation of heavier content of the water that will be accumulated in the periphery of the bowl and will be discharged when the bowl opens. The oil that is lighter than the water will, through the central part of the bowl, flow out of it into the sludge tank. As the centrifugal force is far much stronger than the gravity principle used in the stationary type of OWS, the separation is greater in this type of OWS. Click on the button to view the oily water separator's principle. Oil Content Monitor, OCM. The Oil Content Monitor, OCM, is an electronic device that controls the quality of the water that is flowing out of the oil water separator. In case the oil content in the water is higher than 15 ppm, it will trigger an alarm and activate a three-way valve directing the flow of the water back into the bilge water holding tank. The OCM performs an analysis using ultraviolet fluorescence. It is based on the fact that oil fluoresces more readily than water does. The required value is calibrated, and when it is reached, an alarm is activated. Section 4. Common oily bilge water piping system on a vessel. Common oily bilge water piping system on a vessel. Click on the images to learn more. Bilge wells. The engine room bilge wells are usually positioned in the engine room for the efficient collection of leakages coming from water pumps and coolers. They are located at the very bottom of the engine room. Usually, in the forward part of the engine room, there are two bilge wells, on the port side and starboard side, and one or two in the aft part of the engine room. There is often a recess bilge well below the main engine flywheel. In case there is a shaft tunnel in the engine space, there will be a bilge well, too. Primary bilge tank. There is sometimes a primary bilge tank. The purpose of this tank is to eliminate any possible presence of oil in the bilge water during the transfer. So, the water is delivered to the primary bilge tank from where it is flowing to the bilge tank. Because of its purpose, the primary bilge tank has 2 or 3 test cocks vertically aligned. In the case when the oil is present in the top, or top 2 test cocks, transfer to the bilge tank should be stopped and the valve on the top of the tank will be opened. Thus, the oil will be transferred to the sludge tank until the water starts to flow from the top test cock. At that moment, the valve to the bilge tank should be reopened and the valve to the sludge tank is closed. Click on the button to view the diagram of bilge tank. The purpose of a bilge water holding tank is the collection of bilge water accumulated in the bilge wells. The collected water will be disposed through the oily water separator overboard, or, in some special cases, it will be disposed to shore facilities. The oily bilge water tank, if built in, should be noted in Item 3.3 Supplement to the International Oil Pollution Prevention Certificate. The capacity of the tank depends on the main engine power. For example, if the engine power ranges between 1000 and 20,000 kilowatts, the formula applied is capacity, meter cubed, equals engine power kilowatt by 250. In the case that on the vessel exists an integrated bilge water treatment system, the size of the tank may be reduced. When deciding the size of the tank, it should be taken in consideration that the oil water separator is not frequently used, and that the vessel can sail in special areas, coastal waters, or be in some port without needing to use it. Integrated Bilge Treatment System, IBTS. The concept of IBTS is the separation of oily drains from water drains, reducing in that way the generation of oily bilge water in the machinery space. A typical system consists of clean drains, sludge, and oily bilge water. Click on the boxes to learn more. Clean drains. Main engine air cooler drain, cooling fresh water, and seawater drains and steam drain or boiler water. They may be collected in a clean drain tank, and from there pumped directly overboard. Sludge. All drains from oil tank coamings, main engine under piston drains, compressed air drains, oil mist drain, purifiers drain, oil water separator drain, drain from primary bilge tank if built in, and some other drains where there is a high possibility of oil being present. Oily bilge water. Drains from engine room scuppers and engine room bilge wells. Sludge. All drains from oil tank coamings, main engine under piston drains, compressed air drains, oil mist drain. Clean drains. Main engine air cooler drain, cooling fresh water. Bilge and fire pump system. There are two piping systems in the oily bilge systems. Click on the box. Fire pump system. The bilge piping system is connected to a bilge and fire pump. This system may be used in the case of emergency, for example, in the case of engine room flooding or in case of a fire. The system should never be blanked off, because it must always be available. The diameter of pipes in millimeters is calculated based on the length, breadth, and molded depth of the bulkhead deck, all in meters. In every bilge well is fitted the suction pipe of the system provided with a mud box. Click on the image to enlarge the diagram. boxes to learn more. Bilge system. Usually, when an integrated bilge treatment system is used, the same pump is used for oily bilge water internal transfer, and as an oily water separator service pump. The pump is usually of the piston type, with a capacity of up to 5 cubic meter. The piping system must be installed in all bilge wells, but it must be completely separated from the bilge system. The main bilge suction pipe should not have a bore less than 63 mm and bigger than 100 mm, and the branch pipes should not have a bore less than 50 mm. Click on the image to enlarge the diagram. Bilge system. Usually, when an emergency bilge suction. Emergency bilge suction is a very important additional part of the bilge. Emergency bilge suction is designed for the case of significant ingress of the sea water that cannot be handled with the bilge pump. It might be considered as part of the cooling system, because the valve is usually connected to a main seawater cooling pump. In case the quantity of sea water that is penetrating in the engine room cannot be successfully handled with the bilge pump, the valve will be opened, and the sea suction valve on the main seawater cooling pump will be closed. The sea water from the engine room bilges will be used as cooling water. In some cases, this valve is connected to some other big pump. In normal conditions, this valve must be closed at all times. Engine room bilge management. Bilge wells are at the bottom of the engine room, thus collecting leakages, wastes, and condensates that will be transferred into the bilge water holding tank. As you could see, clean bilges will greatly contribute to the clean condition of the bilge water holding tank. Maintaining a clean bilge water holding tank is of utmost importance for the most efficient functioning of the oily water separator, OWS, thus avoiding possible pollution. Great care should be taken to prevent accumulation of the oil on the flooring plates and in the bilge. This accumulation is, in most cases, the result of leakage of the machinery or the piping system. It might be the result of some breakdown or maintenance, too. The detected leakage should be eliminated as soon as possible. Great care should be taken about chemicals that are used in the engine room. There are some chemicals that will cause emulsification that might result in oil not being recognized by the Oil Content Monitor, OCM, and may cause pollution. Because of that, great care should be taken to prevent them from draining into the bilge when using them. There are specially designed chemicals for cleaning the engine room bilge that will easily separate from the water when processing it. To reduce the quantity of the bilge water, the clean drain water tank should be used effectively. There should be accumulated clean drain water from the main engine air coolers, water drain from the diesel generator turbocharger when it is in the stop condition, and drain from the air conditioning system. As this accumulated water is clean, it may be pumped directly overboard. It is of the utmost importance to keep drains without clogging. To reduce the water leakages around the shaft of the pumps, whenever possible, a mechanical seal should be applied instead of the standard gland type. To reduce the risk of possible pollution, it is extremely important to keep the engine room bilges clean.
Summary. In this course, you have learnt what oily bilge water is, how to identify oily bilge water, how to operate the equipment installed for handling oily bilge water in the proper way, and What are the requirements of MARPOL Annex 1 regarding oily bilge water? Instruction.